Today we're going to look at section 3.1. Our objectives today are going to understand the concept of congruent figures, and we are going to accurately identify the corresponding parts of figures. So there are some vocabulary words that you're going to want to know. And I've mentioned a couple of these words before, but now we're actually going to physically define them. So one word is theorem. A theorem is a mathematical statement that can be proved. Theorems are something we are going to be using a lot of in the rest of this semester and even next semester in geometry. Okay, so a mathematical statement that can be proved. A postulate is an unproved assumption. So anytime I tell you something is a theorem, I could go ahead and I could state and show you the reasons as to why they are what they're saying they are. If I tell you that something is a postulate, you're just going to have to take my word for it because it's an unproved assumption. Two other vocabulary words, congruence. Okay, that's something that we've been talking about since the very beginning. Congruence means to have the same measure or length. Okay, we can have angles that are congruent. So that's why they have the same measure. We could have segments that are congruent. That's because they are the same length. But now we're going to be talking about congruent triangles. Congruent triangles have all pairs of corresponding parts congruent. And so we're going to talk about what it means when I say corresponding parts. But essentially what we're going to be doing is we are going to be carefully matching up angles that are congruent or segments that are congruent based off of the diagrams of triangles. So here's what I'm talking about. Say I am given that the triangle ABC is congruent to the triangle DEF. So because they're congruent, they are the same size and the same shape. We're going to name all pairs of corresponding parts. So because we're talking about a triangle is made up of three sides. That means that we're going to have three different sets of congruent segments. So let's start there. So if I'm talking about congruent segments, and we're going to have three sets of them, in order for us to be able to name the segments that are congruent, because if you look at the picture, I don't have any markings in my picture. So I can't just look at the picture and say, yep, those two segments are congruent. So that's why the given information and how the letters are arranged is crucial. Notice that the first two letters are A and B in that first triangle ABC. So I'm going to put one tick mark there. Notice that in the second triangle, the first two letters are D and E. So that means that that segment, because it is in the same spot as the segment AB, those are going to be congruent. So I would say that the segment AB is congruent to the segment DE. And notice how A was first and so was D. And so that's why A is first in my segment and so is D. So the order of how we are naming these segments is very important. Notice that I have B and C as the last two letters in that first triangle. I'm going to mark that segment with two tick marks. Notice that E and F are the last two letters of that triangle. So I'm going to mark that with two tick marks. Those two sets of segments are congruent. So I can say that the segment BC is congruent to the segment EF. So once again, B was in the middle, so was E. That's why both of those are in the same spot when we're naming our segments that are congruent. They are corresponding parts. Notice that then the last segments that we have are A and C and D and F. So segment AC, notice how first and last letter is going to be congruent to then the first and the last letter, so segment DF. Okay, so those are all the segments that are congruent based off of this given information. But that's not the only thing that has corresponding parts. If there's three sides, there's also three angles. So that's why there are actually a total of 6 pairs of corresponding parts that are going to all be congruent based off the congruent triangles. And so because these triangles are individual, meaning that they're not attached to each other, each vertex is a single vertex. I don't see multiple angles at A or at B or at C or at D or at E or at F. So that means that I can literally just name the angles with one letter. So if I say angle A, because that's the first letter in that triangle, I have to go to the first letter in the second triangle, so that would be D. So that's why angle A and angle D would be able to be marked the same. They are in the same spot in our naming of those congruent triangles, so those angles are congruent. So that means that angle B gets to be congruent to angle E. Notice how they are both in the middle of those triangles. And so that leaves us with angle C being congruent to angle F. So there are my 6 pieces that make up the triangles. Those are all the pairs of corresponding parts. And so we can do the same thing again. We just don't necessarily have a picture to help guide us. So that's why it's crucial that we're looking at the order of the letters. So because we are given 2 triangles congruent, that means that we have 6 different pieces of corresponding parts that are going to be congruent. We'll have 3 sets of segments and 3 sets of angles. So this time I'm going to start with the angles. Notice that I don't see any letters that are the same in either of those triangles. So once again, that means that we can name them with one letter. So angle D is going to be congruent since D was first. Angle C would be congruent to it because letter C was first over there. So that means that angle O, which is in the middle, is congruent to angle A, which is also in the middle. So then angle G is congruent to angle T. If I look at my segments, I see DO as a segment. They're the first 2 letters. That's going to be congruent to CA as a segment because those are the first 2 letters. Then I can go to the last 2 letters. So OG, that's going to be congruent to the segment of AT, which are also the last 2 letters. And then finally, I can go to the first and the last letter. So DG, that segment is congruent to the segment of CT. And those are the names of all the pairs of corresponding parts. So I would suggest that you pause the video. I'm giving you these 2 triangles to be congruent. Please name all the pairs of corresponding parts. I gave you one set of them. You name the other. So hopefully you got these correct. If you're following the letters, notice that N is in the last and then R is first. So when I go over to the other triangle, I have to go last followed by first. So that's why it was the segment YS. Then we have the middle and the last letter, so middle and the last letter, so KY. And then first and middle, so then first and middle, so SK. Notice that with angle R, I could just use one letter, so angle S, they're both first. But then with the other 2, I used 3 letters. So once again, you have to follow the order of the letters. So because it says angle NAR, it was last, first, and then, it was last, middle, and then first. So that's how I have to follow it when I name the other angle with the other triangle, last, middle, first. So angle YKS. And then same idea. If I have for angle R and A, because it's first, last, middle, then I have to go first, last, middle, so angle SYK. All right, so in this diagram, I'm telling us that the triangle KIT is congruent to the triangle KET. We're going to name all the pairs of corresponding parts. And in this, they gave us a diagram, so we can even use the picture to help us out. Notice that I see that the segment KI has 1 tick mark, and so does KE. Notice how I put the K's first in both of those, because if I'm looking at the triangles, K is first in both of those triangles. I have the segment IT that has 2 tick marks. Notice that ET has 2 tick marks. Notice that how I named it, well, I've got the I and the E in the middle, so that's why those were in the same spot. Notice that the T's were last, so they need to be in the same spot. Also, based off of my picture, I see that angle I is congruent to angle E. I got to use one letter because there's only one angle at I and one angle at E. Notice that the angles up here by vertex K are marked congruent, and they actually gave me numbers. So we could use the letters or we can use the numbers. So angle 1 is congruent to angle 2. I'm going to use the letters just to kind of show you. So I'd have to use 3 letters. So I have to say something like angle IKT. Okay, I have to use 3 letters. K has to be in the middle. So then that would be congruent to the angle. So since I started with I have to start with E and then KT. Notice how we also have angle 3 and angle 4 marked the same. I'm going to use letters. Notice that T has to be the vertex. So I'm going to say angle ITK, which means that it'd be angle ETK as well. So that looks like everything that's marked up in my picture. But if you count, there's 1, 2, 3, 4, 5 things. But normally when you have congruent triangles, you have 6 pairs of corresponding parts that are congruent. So it says, what do we notice about one of the pairs? Well, we actually haven't found that 6th pair yet, so we have to name that. But notice that there was nothing else marked in the picture. But it happened to be this segment right here that wasn't marked, but notice that that would be segment KT for the first triangle, but it's also segment KT for the second triangle. So what we notice about one of the pairs is that one pair is the same segment. Okay? And so that is not going to be something that's unusual, especially in this case where we can see a picture where notice that those 2 triangles are connected together from that segment of KT. So we actually have our first postulate to look at. So remember, a postulate is an unproved assumption. We call this postulate the reflexive property. So the reflexive property says that any angle or segment is congruent to itself. Okay, just like in the previous problem, segment KT is congruent to segment KT. It's congruent to itself. That's because we have this reflexive property. So we're going to look at a couple of examples, and it says what else needs to be marked congruent in the picture in order to say that the 2 triangles are congruent. So if we start looking at everything, notice that we've got the triangle up here, and then down here we've got E with a right angle, we've got T with a right angle. So we have right triangles in this picture. Notice that we have several segments that are marked the same within each of those triangles. And then we've got a dot here, a dot there. So those angles are congruent. We've got the marking here and the marking there. So those angles are congruent. So it looks like all the angles are marked. So it looks like we're missing one of the segments. Notice that the segment that we're missing happens to be a segment that is shared between the 2 triangles. That's this segment right here. So that would be that segment RC. Okay, so it says what else needs to be marked congruent in order to state that the 2 triangles are congruent. So segment RC is going to have to be congruent to the segment. And so in this case, I'm going to say segments then CR. Okay, so they are the same segments, but I have to have the letters flipped around this time, unlike in the other problem, because down here, well, it says what property do we call this? So the fact that these 2 are the same segment being congruent to each other, that's the reflexive property. Okay, but the reason why I had those letters flipped around is because notice that if I'm looking at like the bottom triangle and I'm naming that segment that I have highlighted, I started down at R, which has that little dot, and then it's heading towards C, which has that marking inside of the vertex. So then if I then take a look at the top triangle, I want to start by the dot and go to the other marking. So up here, the dot is by C first. Okay, so the order of the letters matter. So then down here, when we're naming the triangle, notice that E is first. Well, that deals with then angle T in the other triangle because they're both right angles. Since I started with R in that middle, but notice how it's marked like that. Well, angle C is marked like that in the second triangle, and then followed by R. So notice how in the way that we named it, R is in the middle, C is last, and then over here, C is in the middle and R is last. Okay, so it is going to be important that we're paying very close attention to how we're going to be naming these segments. All right, in this one it says, we are given that point E is the midpoint of the segment TP. So we know what the word midpoint is. We've been talking about it since chapter 1. If E is the midpoint, it's going to divide that segment into two congruent segments. So I'm going to mark it with 2 tick marks. So that means that the segment TE and PE are congruent. So then it says, what else needs to be marked congruent in the picture in order to say that the two triangles are congruent? So it happens to be, if I'm looking at, I'll highlight this triangle right here that has a bunch of markings. So this is the triangle where we've got R, T, and E. And then if I highlight over here, here's the other triangle that has all of the markings. Okay, so in both of those triangles, we have all of the sides marked up. So that's not what's missing. Notice how at the top, angle R has 2 dots, and so does S. T has 1 dot, so does P. But if you look at the other markings, those markings actually are not for the angles that are inside of the triangles. They go past the triangle. Okay, this marking over here is for angle REP. And then this angle that is marked is really the angle SET. Those are not angles of my triangle. So it looks like we're missing this angle and this angle. Okay, so that would have to be that the angle RET has to be congruent to the angle. And so because I started with R and it has 2 dots, I got to start up at S, then go to E, and then go to P. So once again, notice that T and P have the same markings. They need to be in the same spot. So what statement justifies why those 2 angles are congruent? Notice that what we have were 2 big angles and we created 2 smaller angles. Notice that this over here, that angle of RES is where those 2 angles that were marked overlapped. So to go from something big to something small, hopefully we remember back in chapter 2, that's because of the subtraction property. So to get those 2 angles that we said were congruent was because we took that big angle of angle REP and we subtracted what I have highlighted in blue, which is the angle RES. So then the angle that was on the other side, angle SET, that was the big angle, I once again subtracted what I have in blue, RES. And so the subtraction property gets us those 2 angles congruent. Now, if I name my triangles, if I said triangle SPE, well, S has 2 marks, so does R. P has 1 mark, so does T, and then we follow it by E. All right, what else needs to be marked congruent in the picture in order to say that the 2 triangles are congruent? So if we look, notice that the 2 triangles of OBW happens to have all 3 segments marked. So that means that we're looking at angles. Notice that angle O is marked and so is angle B. So it means that angle 1 is the angle that we need to be talking about. If I look at the other triangle, all the sides are marked. Notice angle T is marked, angle Y is marked, angle 2 is not. So I would have to say that angle 1 is congruent to angle 2. Well, what theorem is going to justify this? Hopefully we notice that those 2 angles share a vertex at W. They are directly across from each other. This is because vertical angles are congruent. And so now if I name the two congruent triangles, we have the triangle BOW. So looking at the markings, B is marked the same as Y. O is marked the same as T. And so then the W's are technically marked the same as well. Okay, so that's us understanding the concept of congruent figures and then accurately identifying the corresponding parts of figures.